Let's pick up where we left off in lesson 8-7.
Yeah.
Last lesson.
Let's go.
Okay, we had made our way through horizontal axis of revolution, and we were starting to talk about vertical axis of revolution, yes?
Mm-hmm.
We had our first situation set up, and we were ready to set up our second situation. Are we there?
Yes.
Okay, so notice we're rotating around x equals c, so our rotation is over here this time, right? We need to talk big R and little r. Big R is going to go from our curve, which keep in mind, our curve is going to be, I almost started to say f of x, but we need to think about this in terms of x equals f of y, because we're rotating around a vertical axis, we're going to be in terms of y. Big R is going to go all the way from the curve over to what we're rotating around. Little r is going to go from, whoops, there to there, correct? Okay. Thoughts on what big R is?
F of y plus c.
Okay. Because officially it's f of y minus c, but we know in this case c is going to be negative. So f of y minus negative c, which, yes, is f of y plus c. How was I writing them yesterday? I don't even remember.
You did the negatives.
Minus negative, and then change it to a plus if you want. I put that in there just so if you look back at it, you remember. What's little r?
C.
The distance from 0 to c is c, essentially. You can think of it as 0 minus c. Remember, we're doing left minus right. Actually, I should say 0 minus negative c, shouldn't I? But it is the same thing as just saying c. That distance is a distance of c. And remember, we're getting ready to square it, aren't we? So positive versus negative isn't going to matter there. Okay, there's my start for you. Volume is equal to what?
Pi.
Pi. There we go. Get the easy one out of the way.
Integral.
Integral.
A to B.
A to B. Notice my A and B are y values this time, right? Big R squared minus little r squared. So f of y minus negative c, or f of y plus c, quantity squared, minus c squared times dy. Keep it all in terms of y. This one could be interesting. I have a feeling I should have shifted everything up, but too late now. Okay, what do you guys got on the next one? There's our C we're rotating around, yes? We need to talk about big R and little r. Now, as we're looking at this, axis of rotation to the farthest one is going to be my big R. Axis of rotation to my closest one is going to be little r. So what would you call big R? How would you define big R there? Okay, we're going right minus left. So C minus G of Y. What about little r? C minus F of Y. Okay, set it up. Pi times the integral from A to B. Big R squared, which is going to be C minus G of Y quantity squared minus little r squared C minus F of Y quantity squared times dy. Okay. Last one. The first one, these didn't seem repetitive. This seems repetitive now, doesn't it? Is that good? That means you know what you're doing? Okay. So, we got my axis of rotation. Big R is from outside to axis of revolution. Little r is from inside to axis of revolution. Good to know it's not just me that's feeling repetitive. Okay, what is big R?
Oh, shoot. We might have-
F of y plus c. It's minus the negative c value, so it's going to become plus c. Little r is going to be, well, c is negative because it's in the negative location. So c is going to be a negative value there.
Oh,
So like if c was negative 2, it's going to end up being g of y minus negative 2, which ends up becoming plus 2. Okay. Which is why I hesitate. I know if you look in her answer key, she just says plus c. And I hesitate to do that just because I want you guys to realize it's not just an automatic plus there. It's because it's a negative. So easy to do it. Okay, shall we try 5? Oh, wait. I guess, am I supposed to write this? Did you already write it without me, though? Pi times the integral. Gosh darn it, this is why I went higher on the other side. Of big R squared. So f of y minus negative c quantity squared minus little r squared. G of y minus negative c quantity squared times dy. Now, here's the real deal. Can you apply it, right? Number 5. Find the volume approximation of the solid generated by revolving the region bounded by y equals the cube root of x, the x-axis, and the line x equals 1 about the line x equals 2. The battle right there, yes? Trying to get this all graphed. What does this look like? Now, y equals cube root of x. Can you visualize that graph? If you look at my notes, you'll see white out because I graphed y equals x cubed at first. Totally read this wrong. But x cubed is the one that does this, right? Cube root of x is the one, it's the sideways version of it, yes? So it almost kind of looks like, from the origin over, it almost kind of looks like a square root graph, doesn't it? And I don't know if I have my shape exactly right, but it's something like that, right? Good enough? Let the calculators tell you specifically if you don't care for mine. Now, I probably should not have drawn that all the way over. I probably need to end it because let's see. So y equals cube root of x, the x-axis, so that's just telling us our bottom border, yes? And the line, x equals 1. Where is x equals 1? Not all the way over there, is it? So line x equals 1 just means we are going to be looking at this piece right here, yes? Now, in all honesty, I like my extra piece, but let's see. Well, I erased a little too much, but there we go. I'm going to erase a little bit of that because the other thing we're getting ready to do is we're getting ready to rotate, yes? And what are we rotating around?
About x equals 2.
We're rotating about x equals 2. If we're rotating about x equals 2, I just didn't want that line in there clogging everything up. So me personally, what I did. Okay, we got it? We're going to have to know some information before we set up our integral, yes? What are we going to have to know? Or what are you finding right now? Did you find big R, little r? Big R is going to go from the farthest curve to the axis of revolution. Little r, the closer curve. So there's little r, there's big R. What would you say about big R? Yes and no. He says 2 minus the cube root of x. I have an issue with that.
In terms of y. Yeah.
We have to, because we're rotating around a vertical axis, we need it in terms of y. Now, setup, is he correct in a way? It's going to be 2 minus the function, yes? But we're not going to do the function in terms of x. We need to go back and think, what do we know about y equals cube root of x? That's going to be x is y cubed, yes? So what am I really going to want Jacob to say instead? 2 minus y cubed. So not wrong, but not what we can put in there, yes? Okay? What about little r? Big math here. Yeah. Little r is 2 minus 1, isn't it? Axis of resolution is 2. Closest piece is 1. 2 minus 1, which is going to be 1. Okay, you ready? Let's do some math. Let's set it up. Volume is pi. This is the other math we haven't done yet. Times the integral of what?
0 to 1.
Y.
The y value for 1 is going to be 1.
Okay.
So when x is 1, y.
Okay. So what do I want to say here? This ordered pair here is 1, 0, yes? Or you could look at this ordered pair here. It's 0 to 0, or it's 0, 0, yes? What's this ordered pair up here? When x equals 1, y is 1, yes? And which boundaries are we using? It's one of those that you could go wrong and we'd never know it. Because you've got zeros in both places, ones in both places, but we're using our y values, so 0 to 1, yes? Lower boundary, upper boundary. Okay. Big R squared, so 2 minus y cubed, quantity squared, minus little r, 2 minus 1, quantity squared, or if you want to go ahead and put the 1 in, that's fine. And then don't forget at the end, times dy. So it's pi times the integral from 0 to 1 of 2 minus y cubed, quantity squared, minus 1, if you will, dy. What direction would you like to take from here?
It has a calculator.
It has a calculator symbol by it. Do I have to go any farther by hand? Now, in all honesty, could we do this one by hand?
Yeah.
Oh yeah, you could. I'm kind of surprised there's a calculator symbol. Oh, why is there? I have a decimal answer. Must not, I don't know. But, okay. So throw it in the calculators. Excuse me. And you get a calculator answer, unless you really want to review going through all that work. But we've done that a lot lately. And we've got the next two coming up we have to do by hand. Well, don't have to, but it, doesn't give us the calculator output. So. Now, I will say half the battle on this is entering all the parentheses correct, yes? Huh?
What are we supposed to get?
I don't know. I was waiting. What are you guys getting?
27.
I have 6.7319 written down, which if I go to my AP 3 decimal places, 6.732.
Jeez.
Must be the day for it. If you're not getting that type of answer on the calculator, you need to practice, try and figure out where, because the parentheses kind of matter there, don't they? So, okay. I'm ready to set up 6 when you guys are. Okay, y equals x squared, y equals 4, about the line, x equals 3. So what is this dotted thing already drawn in? That is x equal 3 that we will be rotating around. Y equals x squared is parabola. What's y equals 4? Horizontal line that's going to top it off, yes? Now, with that in mind, you kind of have to do you kind of have to think about it. Okay? Y equals x squared. It's a full parabola here, guys. They don't say anything that makes me believe I should only do half a parabola. Okay? They don't have any requirements or anything about that it's just in the first quadrant. So we have something that looks like that. And we're going to be rotating that whole thing, right? Mine's not drawn very well, but you get the idea. Okay, big R, little r. Big R is going from axis of revolution to the far side. Little r is going from axis of revolution to the close side. Okay? Now, as we start talking about big R and little r, what do we have to consider? This is a vertical axis of revolution, so we need to be working in terms of y, because it's vertical like a y-axis, so we're working in terms of y. Our original equation was y equals x squared. So what do you know when you solve that? And it's not just the square root of y, it is plus or minus the square root of y. That matters. Because, so when we go with big R, what's big R going to be? Okay. Officially, it's going to be 3, and then this half over here is going to be x equals negative square root of y. So what I would say is 3 minus negative square root of y, which is, of course, plus square root of y. What's that mean, little r? This is going to be using the positive square root of y. So it's going to be 3 minus square root of y. Okay? And don't ever feel like you guys have to put the minus negative in there. I just do that because you know where your plus sign came from then. Okay? So, I forgot, there's blanks over here, aren't there? Okay, when they say outer radius, that's really big R, yes? So 3 minus negative square root of y, or 3 plus square root of y. Inner radius, so that's little r. That's going to be 3 minus square root of y. Method? This is a washer. This is not a disk. This is a washer because we had to have a big hole in, or big R and a little r.
Will it ever be this for the protocol?
It could be. It could, yes. It could be. And
I've not had one at all.
we're not done with notes, are we? Okay.
Is there one?
Yes. Okay. Okay, guys. Did you set up? V equals pi times the integral. What did your teacher skip over again? I didn't skip over, I guess. We just have to go back and do it. What integral values do I want? If I look at all my important points there, vertex is at 0, 0. This point is at when y equals 4, which is the ordered pair 2, 4. So the values I'm going to need are the y value of 0 and 4. Big R squared, so 3 plus square root of y, quantity squared, minus little r squared, 3 minus square root of y, quantity squared, times dy. And no calculator symbol. So let's do some math. Pi times the integral from 0 to 4. What do I need to do with these? We're foiling. 3 times 3 is 9, plus 3 times square root of y is 3 square root of y, plus 3 square root of y is going to be 6 square root of y, plus square root of y times square root of y is going to be y, minus, next parenthesis, 3 times 3 is 9. 3 times negative square root of y, negative 3 square root of y. Then there's going to be another negative 3 square root of y, so we're going to say minus 6 square root of y. And then negative square root of y times negative square root of y is going to be another plus y times dy. And then clean it up. Does it really go that nice? It does, doesn't it?
I'm just gonna
12 square root of y? Is that what you guys are saying it sounds like? 9 minus 9 cancels, y minus y cancels. I end up with 12 square root of y dy. I say that nice just because we're down to one term. However, we still have to integrate a square root, don't we? Okay, pi times. And actually, okay, so there's pi, there's 12. What happens when you integrate the square root of y? It was y to the 1/2, so now it's going to be y to the 3/2 divided by 3/2, which is times 2/3. Evaluated from 0 to 4. Now, maybe you guys got all fancy and got that all cleaned up right away. I did not. So, what is that going to be? 8 pi. Officially, it is 8 pi times y to the 3/2 evaluated from 0 to 4. Well, 8 pi happens when I do y, or 4 to the 3 halves? Square root of 4 is 2. 2 to the third is 8. Minus 0 if you want to be official. We end up with 64 pi. Started to question myself because I didn't remember that being the answer key answer, but okay. If you do this on the calculator, you're going to get an answer, but it won't be an exact answer, right? And this is an exact answer. Okay? 7 when you're ready. Unless you have a question on 6. Fun part on 7, you can start drawing that picture, yeah? We draw these pictures because if you're doing this without the calculator, you're going to have to be able to visualize a picture here. Okay. Y equals 2 square root of x. Y equals x. About the line, x equals negative 2. So there's my rotation. What do you guys know about 2 square root of x? What do you know about square root of x? Square root of x is the half of parabola, yes? What's the 2 do to it? Vertically stretches it, so it just means it goes up a little higher. Okay? So in other words, like for instance, if I'm saying this is the square root of x, then 2 square root of x just does that. Does that make sense? You don't need to draw both. I'm just trying to give you guys an idea. Now, for our purposes, how exact does it have to be? Not very as far as I'm concerned. Okay? What does y equal x do? That's that perfect diagonal line. Guess what we're going to get here? It's going to do something like that, isn't it? So we're going to have, every time I think and draw this, it turns out really tiny, but we're going to have this little sliver here, aren't we? And that was the idea that this is y equals x. This was y equals 2 square root of x. Okay. Outer radius, or big R, goes from the outside to the axis of rotation. Little r goes from the inside. And what should we probably talk about before we set up our outer and inner radius? Yeah. Y equals x, x equals y, piece of cake, right? You've got to get that other one solved there, okay? So, hey. That's what we're saying it for. When is this? Well, they won't. Okay, well, right now, so we need to put that done. And then the other thing I'm going to say is, I've got questions. They're going to prove that's a Thursday. I mean, you know, just because Thursday, it's the day before break, and so I don't know if they'll approve. I think you're going to have other documentation if you want to get that Thursday approved. Okay? So, but you need to get stuff caught up. Okay? Okay. What'd you guys find out? Let's see. Y equals 2 square root of x. Did you guys divide by 2 or did you square first? You guys are way past this part at this point, aren't you? Yeah. If you can either do it either way. So if we divide by 2, then we have y over 2 equals square root of x. If we square this, we have x equals y squared over 4. Okay? One variation or another. If you prefer, I'm trying to look and see what I did in my notes. The other option, if you don't like that 4 underneath there, you could also think of this as 1/4 y squared, right? Because we're going to be integrating this here in a little bit, or multiplying it, so. Okay, what's your outer radius? Did you figure that out? We can go ahead and answer that. What's the method? Which technically, I mean, you kind of have to answer that as you talk about big R and little r. Okay, so what's big R? Y minus -2, which is y plus 2. Does big R still exist?
I think they would have been, to be honest.
Okay, just wondering. Okay. Inner radius? I just haven't seen one in years because the one in Kokomo's been gone for years. So.
Big R is?
I know what big K is.
You get Circle K.
Okay, inner radius. What do you guys use for inner radius? 1/4 y squared minus -2, which becomes 1/4 y squared plus 2. Yes? Okay. Well, I at least knew what you meant when you said big R. I'll be honest, I'm kind of impressed you knew what big R was.
Oh, my daddy used to do it all.
See, I thought they'd been gone longer than that, honestly, but. Okay, pi times. Did you guys already find your boundaries?
Yeah.
I never remember till I get over there. Obviously, they intersect at 0, 0. Where else do these two graphs intersect?
If I did my math right.
Maybe.
Oh, yeah, that's how
Yeah, I agree with 4, 4.
Yes.
Okay. Now, I can plug 4, 4 in. I know y equals x works. Square root of 4 is 2 times 2 is going to be 4. If you're saying, whoa, how'd you do that? Set the two equations equal to each other.
Oh, we can do that.
Yeah.
Oh, wait. What am I doing? Mrs. Sargent.
I know you can do that.
I've
So.
had all day.
So anyways, you could solve it like this as well. If we square both sides, it's x squared equals 4x. If I subtract my 4x over, x squared minus 4x equals 0. If I factor, x times x minus 4, and I would have intersection points for x's of 0 and 4. I just went through that really quick, and maybe I shouldn't have, but you can always set, if you have two equations, in this case they were y equals, so I set them equal to x, and found my x's. You can always do that.
Can you set the y squared?
Yes, if you had both equations that were x equals, and you could set the y pieces equal to each other and solve as well. And I could have done that, because I guess I do have that right here, don't I? So I could have just as easily done that. So, okay. Regardless, 0 to 4, it's another one you could mess it up and still get it right. Okay. So, if I take the cleaned up version, y plus 2 squared minus 1/4 y squared plus 2 quantity squared times dy. Okay. Are you guys ahead of me at all on this?
Yeah, I have the first.
Okay.
Foil done,
You don't like the other foil? Okay. Let's see. Y plus 2 quantity squared. Well, that is an easy one. Y squared plus 2y plus 2y plus 4 minus 1/4 y squared times 1/4 y squared.
Would have y squared, but then just make a y squared. Oh, the kids.
Yeah, I did that math.
1/4 times 1/4 is 1/16. You might be ahead of me.
Oh, I was on.
And then y squared times y squared is y to the 4th. You might be in the next step. I haven't thought that far ahead.
But I got that.
Okay. Oh no. Then 2 times a 4th y squared. Well, 2 times a 4th is going to be 2/4, so a half y squared. But then we're going to have another half y squared.
So y squared.
And a half y squared plus a half y squared is going to be a whole y squared. Plus 4 times dy. Did I get it right? Did you say you hate this game?
Oh, it actually kind of gets
I was say, do we get anything nice out of this?
the y squared is
Well, we didn't get rid of that fraction. However, we did at least go from having 4 types of terms to 2 types of terms. So 6 terms to 2 terms. 4y minus 1/16 y to the 4th is how I wrote mine. Flip them if you prefer and put the negative out front.
So Sergeant, what's that little thing in the corner? That's like a calculator. No,
Hook, line, and sinker. I fell for it. I'm like, what little thing in the corner? Here's the deal, dude. If there had been a calculator, I would not have been doing all of this. I would have, at this point right here, said, calculator, come my way. I would not have done all of this by hand. Just saying. Okay. 4y.
tricks.
Add 1 to the power, divide. 2y squared minus. Add 1 to the power, y to the 5th. Divide by 5. So now it's 1/5 times 1/16, which is 1/80th. Evaluated from 0 to 4.
You know, that number just got
Okay. Plug in 4. 4 squared is 16 times 2 is 32. Minus 4 to the 5th. Well, 4 times 4 is, 16. I need to the 5th. Times another 16 is 256. And 256 times 16.
How is this not a calculator?
1,024 over 80. And this would be minus zeros, right? Okay. Now, if you use your calculator, you will find that 1,000 over 24 over 80, 1,024 over 80 does simplify. It does reduce. So you don't have to have a common denominator of 80. Because 1,024 over 80 cleans up to be 64 over 5. And then you only have to get a common denominator of 5. And 32 times 5 is 160, I think? Yeah.
I don't like this one.
I have a glass.
Wait, so that's
96 pi over 5? Ethan, you'll like the next page.
Dude, no way. My favorite.
Calculator times 3.
They gave us plenty of examples.
They did. And here's what, I mean, well, you'll find out as we go. This page is kind of our cleanup page at this point.
Oh, homework comes next.
Okay.
3 pages. They couldn't have just given us a 1-page homework for the end.
Okay, you guys got what you need here? Okay. So if it's a calculator problem, really the big deal is all about the setup, right?
No.
That's what we're, and in all honesty, it's not that we couldn't do these by hand. Now there's one that I maybe wouldn't want to do by hand, but most of these I could do by hand pretty easily. We're working about the setup. Okay. X equals e to the y. X equals 1 and y equals 1. About the line, y equals 1. Got that all in check?
I did.
Sort of.
Okay. So, y equals 1. That's what I'm rotating about. X equals e to the y. I have no idea what that is in that form.
L and X.
If you change the form of this, whether you take the natural log of both sides, or whether you do a left, right, middle, you end up with y equals natural log of x. Because if you think about it as natural log of x equals natural log of e to the y, remember natural log base e of e, those just cancel and we have y, right? So y equals natural log of x.
Question, do we want to put absolute value of x?
Based on that we're pretty much just set up to work in the first quadrant, it's not going to be a big deal.
Okay, but, I mean, I recognized that when I saw
Right.
the limits, but I was like, if it was not.
Well, you just have to remember that we cannot sub a negative value into a natural log.
Okay.
Natural log does not exist in the negatives, so. Okay, now, here's the next trick. What does y equal natural log of x look like? I guess technically it's a calculator problem, but it's a graph you should know.
It's like that cool square root of x, but like it dips lower.
I'm trying to think.
I could tell you
Best
the
way.
coordinate at 1, 0.
Yeah, there's going to be a coordinate 1, 0. I was just trying to think the best way to explain it. And I guess, if you recall, okay, this is not it. This is your exponential graph, yes? This is, I'm not leaving this here, okay? That's y equals e to the x. Our log graph is the one that does that. Does this sound familiar? Now, let me back out and get that extra junk off here. So we're looking for a graph that does this. Now, keep in mind, this is only at 1, isn't it? So we're pretty quickly going to go above 1. And this is where you might check. How do I want to say this? At what value? So e to what value gives me, I'm not saying this right. Because in my brain, I know it's going to cross through that line pretty quickly. Okay? How about we just go with the setting each part equal to each other? When does e to the y equal 1? And e to the y is going to equal 1 when y is what? 0, yes? Okay. That's not what I want to do. I used the wrong one. Okay. That's finding this right here. I wanted to, how do I want to explain this, guys? I'm all of a sudden struggle. I should have said, when does ln x, y equal ln x equal, no, that is what I want to say. Why didn't it work? What am I, okay.
Calculator.
Oh, x equals 1. What?
Okay, this is, I want to say, when does y equal ln x and when does y equal 1 equal to each other? That's what I want to say. That's y equals ln x and y equals 1. Don't mind me. And so when is this happening? If you think of this as e to the first equals x. So when do those intersect? Those are intersecting at the point e, comma, whatever. Well, the natural log of e is going to be 1, or this y value is 1. That's what I really need to say. Not sure why it took me a moment to get there. Just did. Okay. Now,
E1 sounds like graph shit.
where are we rotating, guys? What are we rotating? It's bordered by the graph I drew in. X equals 1. Where is x equals 1? I never drew that in, did I? Where's x equals 1? Yeah, this graph is not very proportional. X equals 1 is this graph right here because what's this point? This point is the ordered pair 1, 0.
Do we have a disk?
Maybe. Okay, so we're going by, bordered by my curvy natural log graph, the vertical line x equals 1, and the rotation line y equals 1. You've got to process that what I'm rotating is that piece right there. Your teacher's not leading you very well, though. And what did Maddie just discover? This is a disk. And it's a disk because I'm bordering what I'm rotating about. It's a disk. Do I have outer radius and inner radius? No, because my inner radius, I'm bordering against it. There is no inner radius. We just need to know the outer radius, essentially. Okay? Now, let me ask before we go any farther.
Yeah.
Am I working this problem in terms of x or y?
X.
And how do I know I'm working it in terms of x?
It's a horizontal.
It's a horizontal axis I'm rotating about, which is just like an x-axis, right? So we're going to be working this in terms of x. When I work this in terms of x, right here is my r value, yes? And what is that distance? If we're going upper minus lower, the upper piece of r is at 1 minus, what's the lower piece? Natural log of x. And then we need to set this up. Pi times, what are my integral boundaries here?
1 to e.
We want this in terms of x, so we're using our x values, and that is going to be 1 to e. When we say big R squared minus little r squared, well, remember disk method, we just said r squared, didn't we? We didn't have big R minus little r, so it's just going to be 1 minus natural log of x, quantity squared, dx. And then you punch it in your calculator. And I have the rounded answer of 1.372. Can you handle if I move on? Because I have 5 minutes left to do 2 problems. It's not happening, guys, but we can at least talk about it a little bit. Okay. As we go back to 9. 9, y equals cube root of x, y equals 0, x equals 8, and then we're revolving around x equals 8. Okay? Y equals cube root of x. Remember graphing this earlier? Does that thing, right? Y equals 0 is the x-axis. X equals 8 is what I'm rotating about, and also the right piece. So what are we rotating? That piece again, yes? What do you notice again? 2 problems in a row. It's a disk problem, which means I just really have to find my outside radius, or my main radius. From the rotation axis to the curve, what are we thinking here? 8's on the right minus, what's the catch? Yeah, this is a vertical axis, so we are in terms of y. So you need to get back to the fact that x is y cubed. So 8 minus y cubed, because it's a vertical axis. Always ask yourself, what are we working at? Vertical axis says I'm going to be working in terms of y's, okay? So, pi that goes through 0, 0, and we need to know That is going to be 8 comma something. And the cube root of 8 is 2. So 8 comma 2. We need our y values. So we're going to be integrating from 0 to 2 of 8 minus y cubed quantity squared dy. $258.508 is my calculator answer. And number 10, are you guys noticing a trend here? Y equals 6 is this line here. And it says we rotate about it. It's also one of my boundaries, yes? So y equals 6, the y-axis, y equals 2 square root of x. This is going to be, I did want it to go up there. Probably had it going up a little too quick, but it's going to do something like that. We know this is going to be at 0, 0. You're going to have to find that intersection point also. It's going to be something comma 6. And if you put in, you try and see 6 here. 2 times what is 6? 2 times 3, and so it would be end up being 9 comma 6. That's just me doing some mental math there because I'm running out of time. But we are rotating this piece here. Are we working in x's or y's? We are working in x's, aren't we? Working in x's because it's a horizontal axis. So again, this is a disk method. Outer radius, upper minus lower. So 6 minus 2 square root of x. Okay. And that gets you the idea. Pi times the integral. It's 0 to 9 because we're in x's. Of 6 minus 2 square root of x, quantity squared, dx. $169.646 in case you care about that answer. There we go, guys.
Last notes.
Last notes.
Yay.
Probably would have gotten done with time to spare, except I got confused. Well, not time to spare, but we would have gotten done better if I had not had issues on 8. But